Morning, and it's a pleasure to be speaking here today about diesel fuel quality and how that impacts mining economics. The mining industry is a huge consumer of diesel fuel. Therefore, fuel costs is a target-rich environment for cost savings. Whether it be for power generation at the mine site or with haul trucks, 80 to 90% of the 20-year life cycle costs of that operation is due to fuel. So proper attention to diesel fuel quality is really key if we want to extract more value, save more money for our miners' fuel bill. Our outline, just going to give you a quick rundown of things I'm going to talk about. Fuel problems, remember it's very, very key. Mining industry diesel consumption, potential solutions that I see in the market, and benchmarking and testing to evaluate the effectiveness of fuel additives, and finally, a fuel quality analysis checklist. So what are some of the common fuel-related problems that the mining industry is seeing today? This is probably just a partial list, but it focuses on the underperformance of the fuel expenditure made by mining companies. Moisture is a key contaminant because it leads to clogged fuel filters, clogged fuel injectors. Poor fuel quality also leads to the incomplete combustion of the diesel fuel, which wastes fuel expenditure dollars. And finally, the long-term problem of compressed maintenance intervals due to poor fuel quality costs mining companies a lot of money. So if we look at the top 5 largest gold producers, we see that the relative gold production from 2005 to 2013 been fairly stable in the 23 to 27 million ounce range. But let's focus now on the increased gallons of diesel fuel required for each ounce of gold produced. Over the last 8 years, it's doubled from around 12.7 to 25.8, or a 9% annual inflation in diesel use. So what are some of the reasons for increased diesel use? Well, we've learned earlier the lower ore grades takes more ore to get the same amount of finished product at the end. Also, deeper mines, longer haul runs, more diesel consumption. But just for the top 5 gold producers, they've consumed over almost 600 million gallons of diesel per year. Let's change the focus from diesel consumption, not in gallons per ounce, but in dollars per ounce. Not only is diesel use per ounce gold increasing, but when we factor in the diesel price increases over the last 8 years, it's about a 1.2% per year inflation rate. Total amount of diesel expenditures by the top 5 gold mining companies is around $1.6 billion. Even without diesel price inflation, the use of diesel to produce gold has been increasing at an alarming rate. So what are mining companies going to do to address this rise in their costs? We need to find ways to get more value out of our fuel expenditure dollars. If you look at the fuel issues, one of the villains of fuel quality and its deterioration is the presence of moisture. This happens the minute diesel is injected into the storage tank, as shown on the far left, in a clean tank. In areas of high humidity, such as South America and Sub-Saharan Africa, lots of humidity, opportunities at refill for moisture entrainment into the tank starts this cycle. Once moisture is inside the tank, as shown by the blue dots on the top part of the tank, second diagram from the left, it hastens the formation of bacteria, gums, and corrosion. All of these factors are bad actors that contribute to poor fuel quality, increased tank maintenance costs, shorter tank maintenance intervals, higher fuel consumption rates, and yes, higher fuel expenditures. The contaminants in the fuel, remember, bacteria, gums, and corrosion act to lower the engine's operational performance. They clog fuel filters and fuel injectors. One of the clearest indications of contamination is the residue left behind in the combustion process. You'll see in the simple burn test, the picture on the top. The left container represents the preferred combustion process. Full hydrocarbon combustion, no residue. The fuel is contributing to the engine's work, and we're getting maximum value for our fuel expenditure. The container on the right has a residue showing incomplete combustion. This residue, think of it as money, fuel expenditure money left on the table. This incomplete combustion process manifests itself also in the black smoke and soot on the bottom picture on the left. The ideal combustion is what the vessel on the left. The poor combustion is one on the right with the black soot and smoke coming from that combustion process. Think of your fuel expenditures from this soot going out the tailpipe of that engine, haul truck, or engine generator. Incomplete combustion leads to shorter maintenance cycles and unnecessary costs, and not getting as much value out of our diesel fuel expenditure. Another adverse effect of poor fuel quality is the engine's ability to provide the maximum power that the equipment manufacturer has prescribed for the fuel expenditure made by the miner. When we examine this thermal image of the combustion process, a few things really jump out. The left combustion has a larger flame, has higher temperatures, a larger flame, more soot, more smoke. Think of the smoke as your fuel expenditure dollars leaving out the exhaust, out the tailpipe of the haul truck or engine. Less productive work for our fuel expenditures. The temperatures are higher on the left, which indicates that more productive work is going out the tailpipe rather than what you're paying for in diesel fuel. Higher combustion chamber temperatures, more engine scarring, point to increased engine wear, compressed maintenance cycles, increased consumption of diesel, and once again, higher costs for diesel. As a certified energy manager, I study this issue and look at ways that we can save money on our diesel fuel expenditures. So this chart shows what an increased fuel value with increased fuel quality means to a miner. On the far left, the diesel demand in liters per month, and at a rough estimate, 50 cents a liter, $2 a gallon price of the diesel, you'll see that achievable 3 and 5% savings net of the additive can yield significant amounts of saving for your operation. Obviously at different diesel demand rates. This is the Jerry Maguire part of my presentation, the show me the money, if you will. So what do we do to correct fuel deterioration, which means that we have less engine work being done, more fuel consumption, higher diesel fuel costs. In order for fuel to do its work inside the engine to reduce overall maintenance, we need three factors, as recommended by the Worldwide Fuel Charter. Number one is oxygenation. This ensures the complete combustion of the diesel fuel inside the combustion chamber. Remember that black smoke and soot is your dollars for fuel leaving out the tailpipe. The second thing is detergency, to ensure a clean fuel system, to clean the injectors, to clean the fuel filters, and prevent those from being clogged. And finally, lubricity. Since 1993, when sulfur limits for low sulfur diesel were at 500 parts per million, the regulations have been strengthened, tightened, that in 2006, the regulation for ultra low sulfur diesel was reduced down to 15 parts per million. This sulfur in the fuel in past years helped to lubricate the engine in the combustion process. Without some way of lubricating the engine with an additive with lubricity, you will get some engine scarring, reduced maintenance intervals for equipment. There are lots of fuel additives out in the marketplace today, as you can easily see. So what's the right one for your application? Which one has the most economic and environmental impact to your bottom line? And which one gives you the performance that is repeatable and reliable for your mining operations and to reduce your diesel costs? So let's look at some metrics. So if additives provide value, what are the performance metrics that we should be interested in? Remember the bad actors, water, bacteria, corrosion. They prevent optimal performance and cost us money. The three fuel quality enhancers that we just talked about for fuel economy must be present: oxygenation, detergency, and lubricity. We should be able to document that our operations are doing the same amount of work, albeit with less fuel consumption, less fuel costs. We ought to see lower emissions, lower combustion temperatures, and longer maintenance intervals for our equipment. So the additive checklist, what things must we have to be able to differentiate the one that does the best performance for our operations? First, we need to look at the chemical composition of that additive. What those chemicals actually do inside the combustion chamber with regards to temperature, uncombusted hydrocarbons, and emissions. What's the correct dose of the additive that we can put into our fuel to not waste additive dollars? Number 5, how do we address this obvious hydrocarbon overconsumption with either a hydrocarbon-based or a synthetic-based additive? Which one is best? How do we get the most work out of our fuel while we reduce fuel consumption and save fuel money? Number 7, is the additive harmful if it's spilled? Because we have operating personnel at risk if there is a spill to make sure that the additive gets put into the tank correctly. How do we improve engine startup capability in areas of cold temperature and high altitude where that can play a major part? And lastly, for water dispersion, does the additive have a way to reduce the surface tension so that not if water and moisture isn't training the tank, but when it is dispersed evenly throughout all the hydrocarbon molecules? As we evaluate additives, I strongly recommend both a lab and a field test. A lab test will tell you that it's safe, but a field test is required to demonstrate performance because it's hard to really emulate the harsh conditions at the mine site at a lab test. Much like a science experiment, the field test must be repeatable and controlled. So you have both a controlled test truck and a control and a test truck or a control and test power generator to change or to monitor your performance. We want to calibrate all the variables that are shown on the slide to make sure that it's compelling, that our final results from having this science experiment actually determines what improvements in performance, meaning lower cost, lower consumption of diesel. The more definitive and disciplined the test that can be done in the field, the more reliably we can rely on our fuel cost saving numbers. So what fuel quality results do we want to document from the field test? We want to evaluate the additive's impact on consumption, costs, and emissions reduction. With the use of an oxygenate, we want to make sure that the fuel is used, it's doing the needed work, but at a lower fuel consumption rate. Once an additive is determined to do no operational harm, we want to monitor and measure the impact of that additive on our long-term maintenance cost, our long-term maintenance interval. So what operational problems that we've had in the past are resolved, if any, from the additives use, such as the startup in cold weather, etc. We need to confirm that the additive fuel savings and increased reliability is present in our backup generator at our mine site. Some of these generators do not use fuel all the time, hence the word backup, so you can have fuel contamination over a long period of weathering of that fuel. We want to document that we have less moisture issues inside the tank, that we have maintain a higher fuel quality. And finally, we want to validate that the trucks and the generator engines are delivering the same power as promised by the manufacturer, albeit at a lower fuel consumption rate. So in summary, there's 5 things to remember. Bad actors for fuel quality are moisture, bacteria, and corrosion. They deteriorate the fuel quality and rob mining companies of their diesel fuel expenditure dollars. Fuel additives need 3 components: oxygenates, detergency, and lubricity. Number 3, better fuel quality leads to longer maintenance intervals and reduced long-term costs. Number 4, always monitor a field test to accurately determine if we're getting the same results that we anticipate when we start this test or science experiment. And lastly, you cannot improve anything you don't measure. As you look at your fuel expenditures, demand accurate and robust tests of all fuel additive candidates to make sure that they definitively determine value to the company. My contact information is there, and I'm open for any and all questions.